Now let's build a try. We start with insert, the operation that adds a new word into the tree. Insert reads the word one character at a time. Let's walk the code. First, we start a pointer called cur at the root. That is where every walk begins. Then we loop over the characters of the word. We keep going until word at index I is the null character, which marks the end of the string. For each character, we compute its slot. Index equals word at index I minus the letter A, so the letter A gives 0, B gives 1, and so on up to 25. Now we check the child of that index. If cur arrow child at index Ix is equal to null, then the node we need is missing. So we create it. We call new node and store it in that slot. This is the only place insert allocates memory. Either way, the child now exists. We step down into it by setting cur to cur arrow child at index Ix, and the loop moves to the next character. After the last character, cur sits on the final node. We set cur arrow is word to 1. That one line is what turns a path into a stored word. One requirement on the helper. New node must zero-initialize every slot of the 26-element child array. A node allocated with a plain malloc and no zeroing leaves 26 garbage pointers, and the very first character lookup on that node reads uninitialized memory. This is the kind of bug that appears to work until it does not. Predict first. Insert cat, then car, then card. How many nodes exist in total when all three are stored, and at which node do the words branch apart? Pause and work it out. The answer is 6 nodes. Cat builds root, then C, a T, which is 3 new nodes. Car adds only the R card adds only the D, so C, a T, R, D is 5 plus the root makes 6. And the words branch apart at the node, where T and R split, and again at the R node. Where car ends and card continues to D, that sharing is exactly what makes the node count so much smaller than the total letter count. Let's insert 2 words, cat first and then car. We build the try one character at a time. We start at the root, the empty string. Nothing is created yet. First character of cat is C. The root has no child for C yet, so we create a new node. Amber means the node was created this step. Second character is A. There is no child for either, so we create another new node under C again amber, because it is brand new. Third character is T. We create one more node for T. It is amber, and it is not a word yet. Reaching a node is not the same as ending a word. Cat ends here, so now we set the is word flag on the T node. It turns green. Green means is word is 1. A word ends exactly here. Cat is stored. Now the second word, car. The first character is C. This time a child for C already exists. We create nothing. We just walk into it. Blue means the node is reused. The second character is A. This node also already exists from cat. So we walk into it too, with no new memory used. The third character is R. There is no child for R, so we create one new node. That amber node is the only allocation car needs. Car ends here, so we set the is word flag on the R node. It turns green. Both words are now stored. Look at the 2 blue nodes. C and A cat and car both pass through them before they split apart. We walked 6 characters in total, but we built only 5 nodes. Sharing the C and a nodes is the whole point of a try. Let's put the whole insert idea side by side. The left column is the concept in plain words, and the right column is the matching line of C1 idea at 2 levels of detail. Start at the root. In C, that is, cur equals root. Cur is the pointer that walks down the tree. For each character of the word. In C, the for loop runs while word at index I is not the null character. Find its slot in the alphabet. In C, index equals word at index I minus the letter A, so each letter maps to a number from 0 to 25. Create the child if it is missing. In C, if cur arrow child at IDX is null, we set it to a new node. Step down into that child. In C, cur becomes cur arrow child at IDX. Notice this line runs whether or not we just created the node. And after the last character, mark a word. In C, cur arrow is word becomes 1. That single assignment is the only thing that distinguishes a stored word from a path that merely exists.